Hello everyone, welcome to Ram Maruti Tutorials. In this video, I'm going to explain you regarding a sum which is a little bit tricky and it deals with arithmetic progression. Okay, the concept says like this: m times nth term is equal to n times nth term. Then show that m plus nth term is equal to 0. That is the concept given for you now. Right. So what is the concept given for you? M times nth term is equal to n times nth term. Show that m plus nth term is equal to 0. That is the given question. So to deal with this sum, let me go a little bit logically, as it is a tricky sum. Let's deal in a tricky way. First, let's come back to this concept. We know nth term of AP, or the last term, an is equal to a plus n minus 1 into d. That's the formula we use to find any term. It might be 4, it might be 6, or any one. Now, fourth term, how we are going to write basing upon that formula, right? That we write it down as a plus 4 minus 1 into d, right? If we are asked to find fourth term, it is a plus 4 minus 1 into d. If we are asked to find the sixth term, a plus 6 minus 1 into d. So, whatever we are asking, that goes here. If it is asked 4, it goes 4 minus 1. If it is asked 6, it goes 6 minus 1. Now, in the same way, if we keep any variable there, if we go ax, that is xth term, then we call it as a plus x minus 1 into d. Whether it might be a number or it's a variable. Now, let's go according to the sum. If you take it as a of bracket or a bracket, means like bracket the term. Of course, it's not possible. Just to make you understand the sum, I'm going like this. A of bracket is equal to a plus bracket minus 1 into d. What I mean to say is, whatever we keep here, that goes there. If we keep a bracket, it goes bracket. Now, let us connect that logic to the sum what we need now. So, what is the sum he is asking? M plus nth term means, if you keep m plus n in this bracket, again the same thing goes here. Okay, that is a plus m plus n minus 1 into d is nothing but r m plus nth term. M plus nth term. Now, if you come back to the question, m times nth term is equal to n times nth term, right? And we are supposed to prove that m plus nth term is 0, means the m plus nth term, this should be 0. Then we can write it down as a m plus n, that is mth term is equal to 0. To get that sum, let us start the sum now. We know mth term a plus m minus 1 into d, nth term a plus n minus 1 into d, and this is the logic what he has given according to the sum. M times nth term is equal to n times nth term. This is nothing but given to us. Now, let's plug in the values of mth term and the nth term and in the given condition or the logic. That is, m times mth term. Mth term is nothing but a plus m minus 1 into d. Now, nth term is nothing but a plus n minus 1 into d. So, this is the equation what he has given in the question. What we are supposed to reach? We need to reach a plus m plus n minus 1 into d is equal to 0. So that we can say m plus nth term is 0. So this is a tricky part. So if you check it out here or towards the left hand side, we are having 0. Means whatever might be here, that should be sent to the other side to make it 0. Right? That's the tricky part. Now what we are supposed to do? Let us simplify inside the bracket to go to the bracket which is outside. What I mean means, inside bracket should be solved first before coming to the outside bracket. So let us come back to the inside brackets. Apply distributive formula. M into d, md. Minus 1 into d, minus d. Here also. So n into d, nd. Minus 1 into d, minus d. So what I have done? Inside the bracket should be solved first. I have done. Now come back to the outside brackets. So see here, if this is the bracket and how many terms are there? We are having 3 terms. Now what is in outside? M. That has to get in how many times? 3 times. Let's get in. M into A, MA. M into MD, M square D. Now M into minus D, minus MD. The same trick is followed here, right? N has to get into the bracket 3 times. n into a, na, n into n, d, n square d, n into minus d, minus nd. So what we got? Towards the right side, we got 3 terms. Towards the left side, we got 3 terms. Now what we are supposed to do? As we need 0 to one side, let us send all the terms which are present here towards the other side. But the trick part is, it has to reach the similar term, the like term. Now if you check it out, I have labeled it clearly for you so that you can understand better. The red and the red, they sound similar. Blue and blue, they sound similar. In the same way, green and green, they sound similar. Why? Because MA, NA. Right? M square D, N square D. MD, ND. So, what I have said? I have said these 3 beside them exactly to the side. That's what you can see here. MA, the NA goes there and becomes minus NA. Right? In the same way, M square D is there. Now I am sending N square D to the other side. It went and became minus. And minus MD is already there. Minus MD is already there. The minus ND shifted to the other side and became plus ND. Right. So the required 0 has come. Now the only part is we have to arrange the entire stuff in the form of a plus m plus n minus 1 into d, so that the required m plus nth term can be reached. So to get that one, let's focus on that. If you check it out, a pair, one more similar pair, and one more similar pair. From this, if you check it out, a's are common in the first 2 terms. A, so I am taking a as common. If I take a as common, what is left over? M minus n, if a is taken common. Now, out of these 2, if you check it out, d is common. So I took d as common. If I pull d outside, what is left over? M square minus n square. Now, if you check it out, d is common here also in the last 2 terms. But the tricky part is, whenever we have minus at the beginning, that should be taken common first. So minus I took it out, and also the common d also I took it out. So what is left over? Here, right, m is left over, but the main part is plus can be written as minus into minus. So if one minus is pulled out, one more minus is inside. Okay, you got it. Now the actual part, see here. Now if you check it out, m minus n, but do we have m minus 1 here? Yes, it's there. What you are guessing is right. So here it is m square minus n square, which is nothing but a square minus b square. So, which is nothing but a plus b into a minus b. Now, as it is dealing in terms of m's and n, m plus n into m minus n. That is the tricky part. So, so see here, m square minus n square, I have written in the form of m plus n into m minus 1. Now, if you check it out, m minus n here, m minus n here, and also m minus n here. All the 3 terms, right? They are having m minus n. Now take out that m minus 1 outside. The m minus n, I pulled it out. M minus n, I pulled it out. M minus n, I pulled it out. So I took common. So if I take m minus 1, what is left over? A. If I remove m minus n outside, what is left over? B into m plus n. If I remove m minus n, what is left over? Minus d. Okay, so slowly and slowly we are reaching to the required a plus m plus n minus 1 into d is equal to 0, so that we can say m plus nth term is equal to 0. Let's come back. So m minus n, what it is doing here? It's multiplying. If it goes to the other side, divides. So send m minus n to the other side, it becomes 0. Right? So no more. Now what is left over? A plus d into m plus n minus d is equal to 0. Now, if you check it out, b and d are similar here, right? We can take out common. But if it is present in all the terms, I might have pulled d out. But d is present in only the second and the third term. Okay, so what I am doing, I am taking d common between only these 2 terms. Therefore, I kept it to the back. Right, see here, d and d, I pulled it out. So if I remove it, what is left over? M plus n minus d into 1. Sure, d into 1 is a d. If I remove d, what is left over? Minus 1. So if you check it out, a plus m plus n minus 1 into d, as we have planned earlier. Come back to the logic now. 4th term, a plus 4 minus 1 into d. 6th term, similarly, a plus m plus n minus 1 into d is nothing but mth term. So here comes our mth term. mth term, m plus 1 is equal to 0. So, m plus 1, m plus nth term is 0. It's proved. Okay guys, so hope you got it. It's a tricky part. Yes, those tricky parts with the logics we can get it. So, hope you are able to understand. Let's come back with the next videos. Thank you.